Hello, good morning, everyone. I think we're going to start the seminar today. My name is Jennifer Ming with the Trade and Invest British Columbia Korea office. On behalf of the Embassy of Canada and Korea Trade Commissioner Service, Canada Hydrogen Association, Alberta Korea office, and Trade and Invest British Columbia Korea office, I would like to warmly welcome all of you and thank you for joining us for the Canada Day seminar. To officially open today's session, I would like to invite Jennifer Rodriguez, Commercial Counselor at the Embassy of Canada and Korea, to deliver the opening remarks. Please join me in giving her a warm round of applause.
Good afternoon, bonjour, annyeonghaseyo, distinguished guests, colleagues, friends. It's my great pleasure to welcome you to this Canada Day seminar on hydrogen. Today we gather not only to highlight the strength of Canada's hydrogen ecosystem, but also to explore opportunities for deeper collaboration between Korea and the global community. Since the launch of H2Meet in 2020, Canada has consistently participated alongside the Canadian Hydrogen Association and our leading hydrogen and fuel cell companies. This event has become an excellent platform for a Canadian organization to reconnect with Korea's key player and to explore a broad range of collaboration opportunities. We're delighted to join the World Hydrogen Expo 2025 once again this year. Canada is home to a thriving hydrogen ecosystem built on decades of innovation, world-class research, and industrial expertise. Canadian innovation is powering zero-emission transportation, decarbonizing heavy industries, and enabling clean energy storage. Today, Canada ranks among the top 10 hydrogen producers in the world, and we are well positioned to be in the top 3 by 2050. Our natural advantages, abundant renewable energy, vast water resources, world-class innovation capabilities, and strong governmental support at both the federal and provincial levels position Canada as a reliable and responsible producer of clean hydrogen. The Government of Canada's hydrogen strategy lays out an ambitious vision to become a global supplier of clean hydrogen with investment in production, distribution, and international collaboration. Hydrogen is also identified as a key pillar of Canada's pathway to net zero emission by 2050. So momentum is building. Across Canada, approximately 80 low-carbon hydrogen projects have been announced, representing over $100 billion in potential investment. And those are dedicated to building out clean energy opportunities. So this reflects the confidence of the industry and government alike in the hydrogen's role as a transformative energy solution. But no country can achieve a net zero future alone. Canada is committed to working with international partners to scale up hydrogen technologies, to harmonize standards, unlock new market, and to strengthen energy security, and also to accelerate the clean energy transition. We see tremendous opportunities to collaborate on research, pilot projects, and supply chain development to turn innovation into impact. I hope that today's seminar will provide you with valuable insight into Canada's expertise, capabilities, and competitive advantages in hydrogen, while showcasing the technologies, the products, and the services of Canada's leading hydrogen and fuel cell companies. I also warmly invite you to visit us at the Canada Pavilion. So we're located at the booth 7D71 to meet the companies that will be presenting today. So thank you. I wish you an engaging and inspiring seminar. 감사합니다.
Thank you for your remarks. I would just like to mention that we do have simultaneous interpretation today. So if you need to use the device, it's channel 5 for Korean and channel 6 for English. Our first presentation today is titled Canada's Hydrogen Roadmap, Building an Economically Prosperous Low-Carbon Future. Please welcome Nicholas Hilario, Vice President of Operations at the Canadian Hydrogen Association.
Good afternoon, everyone. Welcome to today's session. Thank you all for joining us here today. I'm Nicholas Lario, VP of Operations at the Canadian Hydrogen Association. On behalf of our association and our member companies, we're delighted to be back here in Seoul for H2 Meet and happy to provide some updates on Canada's hydrogen sector. Yeah. Just the right click. Oh, okay. Okay, so just some context on the CHA for those of you who may not be familiar with us. So the Canadian Hydrogen Association is a national nonprofit industry association that's represented and supported Canada's hydrogen sector since the 1970s. We represent 200 stakeholders across the value chain, ranging from industry companies to academia and all the way to end users. And our mandate is to support the sector with advocacy, government relations, communications, and networking. Be missing a slide here, but no matter. So the Canadian sector is recognized as a global leader as a result of a 100-year history of pioneering technologies, expertise, and partnerships between industry, government, and academia. Our journey began in 1905 with the invention of the Stuart cell in Ontario, which first split water into hydrogen and oxygen into electricity. And in subsequent decades, we've witnessed a number of milestones, such as the founding of Ballard Power Systems in 1983, which would become a global leader in hydrogen fuel cells, as well as the emergence of a world-class technology and services cluster in British Columbia, the construction of the country's first public hydrogen refueling station in 2018 in British Columbia, all the way to the release of Canada's hydrogen strategy in 2020. Fast forward to today in 2025, and Canada is uniquely positioned as a leader in the global hydrogen economy due to our abundant clean energy resources, strong R&D capacity, world-class companies, and a government framework that is increasingly supportive of hydrogen development. As Jennifer alluded to earlier, we produce over 3 million tons of hydrogen annually, ranking among the top 10 producers globally, and we lead the way in cutting-edge technology with over 100 years of expertise in both electrolyzer technology as well as fuel cell applications. The sector generates around $500 million Canadian annually and employs around 4,000 highly skilled professionals. So why hydrogen for Canada? Hydrogen will play an essential role in meeting Canada's energy needs in the context of energy security, the energy transition, and the broader climate imperative. Whereas electrification is not an option, hydrogen offers Canadian industry a means to reduce their emissions for hard-to-abate sectors and can be transported by leveraging our existing pipeline network. In addition, due to our proximity to key target markets, this positions us obviously for a significant export opportunity. As of 2025, the Canadian sector has seen significant activity across the country with respect to projects and demonstrations. In total, there are 113 projects that have been announced or are under development in some form. The majority of projects are in the feasibility stage, so 10 projects have reached FID. 6 of those are tied to hydrogen production, while there are over a dozen operational projects underway relating to transportation, industry, and mining across the various provinces. This slide also shows the network of regional hubs in British Columbia, Alberta, Ontario, and Quebec, just to highlight a few, which are bringing stakeholders together and tying industry, academic, and research applications all in major clusters. This is a major component of our hydrogen strategy for Canada, and the CHA is working closely with our federal government and partners to support the development of these hydrogen hubs and corridors throughout the country. This slide highlights just the number of stakeholders in the hydrogen value chain in Canada. So as represented here, the value chain in Canada spans all areas of the market, ranging from fuel cell stack developers to hydrogen producers, car manufacturers, research and engineering firms, gas companies, utility companies, you name it. So we have a very vibrant and diverse community of hydrogen stakeholders in Canada. This is just a slide on our regional chapters. So the CHA has a network of regional chapters in BC, Alberta, and Ontario to support local domestic deployment in those jurisdictions. And we invite our our Korean colleagues to connect with the CHA and our members at major industry events coming up in 2026. Just to highlight a few here, H2FD Expo, which is during World Smart Energy Week in Tokyo, Japan in March, the Canadian Hydrogen Convention in Edmonton, Alberta, Canada, as well as the World Hydrogen Summit in Rotterdam. And I just want to wrap up here by showing the array of government support here at the federal level. In terms of regulatory support, funding mechanisms, and investment tax credits, we've seen a groundswell of support from the federal government and provincial governments following the release of the hydrogen strategy in 2020, as well as the provincial roadmaps in subsequent years. I'll close it there, and I'll let the companies speak more about their capabilities. But thank you for your attention.
Thank you, Nicholas, for that informative presentation. If you have a question, please raise your hand after each presentation and a microphone will be brought to you. Next, we have Victor Lee, Counselor and Alberta Government Representative in Korea. He will present hydrogen opportunities from Alberta in the AI era, new potential for Korea-Canada cooperation. Please join me in welcoming Victor.
Okay, good afternoon, distinguished guests, colleagues, and industry partners. My name is Victor Lee, and I'm the Alberta Government Representative at the Canadian Embassy in Seoul. And it is my pleasure to share for the next 10 to 15 minutes about Alberta Korea Office, Alberta Government, and also hydrogen-related opportunities between Alberta and Korea. Okay. So the Alberta Korea office has been in Korea since 1988, and we are co-located at the Canadian Embassy in Seoul. And we are part of the Indo-Pacific team that promotes bilateral trade, attract investment, facilitate R&D partnerships, also in general policy advocacy, but also talent attraction. And our role is to help bilateral relationship and also create economic activities for both Korea and Canada and Alberta. We mainly support Alberta companies wanting to explore opportunities in Korea. However, we also support Korean stakeholders by introducing commercial and R&D opportunities back in Alberta, and also support buyers, investors, or researchers wanting to partner with Alberta. Korea is Alberta's fourth largest trading partner, and especially energy security and food security, those are the key topics that we focus. But when you ask Alberta to many Koreans, they only know about Alberta as somewhere between Toronto and Vancouver, or focus is more on US $60 billion submarine contract potential deal between Korea and Canada. Alberta is somewhere. However, the G7 this year, the Korean president, his first visit to Canada was to Alberta, to Kananaskis, the beautiful Rocky Mountains. And also we are focusing on energy collaboration between Korea and Alberta. But still, Alberta is well known for its Rocky Mountains, Korean TV shows visiting Banff, or the Netflix TV series that will feature Alberta. The global teaser will come out next week. So there's a Netflix Korean show, Korean romantic comedy filmed in Alberta. So it's coming. But Alberta is more than that. Alberta is actually Canada's economic engine with strong competitiveness in energy, life science, agri-food, and creative industry. The province is roughly 7 times the size of South Korea, and with 2 NHL teams, Edmonton Oilers and Calgary Flames. We have a lot of, as you can see, the teams have oil and flames, meaning that we have a lot of oil and gas. We produce about 80% of Canada's oil, about 70% of Canada's gas, and almost over 90% of Canada's commercial blue hydrogen, over 3 million tons per year. Alberta is also home to 2 major universities, University of Calgary and University of Alberta, leaders in hydrogen, AI, and clean technologies and energy safety. Alberta is also known for Canada's hydrogen capital because we have strong companies, researchers, and industry associations and regional hydrogen hubs. But again, we are also leading agri-food. We have actually more cattle, more cows than people, and about 95% of Canada beef coming from Canada to Korea comes from Alberta. And we are well known for life sciences and also creative industries too. And hydrogen is one of our key priorities. Now, when you're filling gas in Korea, you're actually getting Alberta heavy oil. So Hyundai Oil Bank, GS Caltex, SK, they're importing Alberta heavy oil. LNG Canada has started exporting Canadian natural gas. So now Korea is getting Alberta's natural gas as well. About 15 to 20% of Korea's imported propane comes from Alberta-based company. And those are mainly used in Seoul, the taxi. So 1 out of 7 or 8 taxis using propane are using Alberta propane. And hydrogen is also huge potential. As you mentioned, we have a long history of Korea and Canada and Alberta's bilateral trade and investment relationship, in addition to Alberta-Gangwon's 50-year sister province relationship. So discussions have, built on this foundation of deep and long-term relationship. So now let's talk about hydrogen, the trade, investment, and R&D opportunities between Alberta and Korea. Alberta is already Canada's largest hydrogen producer. As I mentioned, over 3 million tons of blue hydrogen being produced. At the same time, Alberta is positioning itself as a key destination for AI data center with its stable energy supply, cold climate, large land availability, and strong innovation ecosystem. AI system requires a lot of clean energy and reliable power, and Alberta has that. And Korea, with its technology and demand for high power energy and data centers, there's a mutual partnership agreement and opportunities. So we have Canada's largest hydrogen, or we're the producer of hydrogen, and also low-cost, clean hydrogen. And then there is a $70 billion investment project in Canada, in Alberta. In the US, there's a Silicon Valley. In Canada, there will be Wonder Valley. Wonder Valley because the investor is coming from, I'm not sure if you know Kevin O'Reilly. He's Mr. Wonderful, his nickname. And he's basically a Trump of Canada, or major businessman in Canada. And he has announced $70 billion the data center project in Alberta using our cold climate and also hydrogen. So there are a lot of opportunities in that field. Now, before talking about specific trade, R&D, and investment opportunities, I would like to highlight one important note about how to work with Canadian government, both federal, provincial, and municipals, in the energy sector. Under the Canadian Constitution, the natural resources and energy fall under provincial government. This means for hydrogen, LNG, CCUS, and critical minerals, Korean government and Korean companies and researchers need to work directly with the provincial government, such as Alberta and of course BC government as well. The collaboration with the federal government remains, of course, very important because we all work together to advance bilateral trade and investment and R&D opportunities. But effective partnership requires coordination from all sides. And understanding this structure, how natural resources fall under provincial government, but environment is shared, these are very important concepts. And if you have any questions, you can let me know after, or our colleagues from the federal ministries. So Alberta, as I mentioned, produces about 80% of Canada's oil, 70% of Canada's gas. It's built on the Western Canada Sedimentary Basin, WCSB. Looks like a beautiful Rocky Mountains, but underneath we have amazing natural resources. Globally speaking, about 3rd largest oil reserves and 4th or 5th largest natural gas reserves are here, and also metallurgical coal and other minerals. The geological foundation also is good for CO2 storage. So I'll mention a little bit after. So because of that, over 50% of Canada's energy projects is in Alberta, and over 50% of Canadian energy job is also in Alberta. And Nicholas also shared this slide, added a little bit. I think you mentioned 130 projects. Out of 130 projects, 80 projects are under construction or announced and actually putting more money into it, so more active. And if you see Western Canada, a lot of projects are in Alberta. Korea's E1 and SK Eco Engineering and KOSPO are very active in Alberta. SK also has a projects in Eastern Canada, but that's for exporting to Europe. Majority of the projects in Western Canada is blue hydrogen in Alberta, some in BC green hydrogen. But as you can see, Alberta has major projects in hydrogen. And Alberta expects to increase our hydrogen production to over, I think, 4 to 5 million tons based on current situation, but mainly coming from blue and gray because we have a really amazing natural gas resources. And those are very competitive priced. And CCS technologies are improving, so we are able to capture almost 98, 99% of CO2, and technology is getting better and better. So CCUS. Alberta has one of the world's most advanced CCUS ecosystem. Shell's Quest project has been capturing million ton of CO2 per year for the past 10 years. They just celebrating 10th anniversary this year. So that means 10 million ton of CO2 has been successfully stored. And the largest I guess Shell's one of the largest global project. And this experience and ecosystem gives Alberta a strong competitiveness in developing low carbon hydrogen and ammonia at commercial scale. So as you can see, most of the CCS availability is in Alberta and a little bit in Saskatchewan. And compared to other provinces or other US states, this is our key strength. And that's why Canada's largest hydrogen convention or Canada's largest CCUS convention are being hosted in Alberta, in Edmonton. Our next Canadian Hydrogen Convention will be April 2026, and I'll be also personally attending together with federal colleagues. If you have any interest in learning more about deepening your insights into Canadian hydrogen sector, please consider this conference. This is a best place to connect with Canada's hydrogen stakeholders. Of course, there are some challenges too. We can talk about R&D opportunities, investment opportunities, but what about trade? Alberta wants to export our blue hydrogen to Korea because we have competitive advantage in the shipping. This is from AltaGas, so the date is a little bit different for natural gas as well as for oil, but it's very similar. Compared to the US Gulf Coast or Middle East, we didn't include Australia because it's very similar to Alberta or Canada, so it's our direct competition. But about the same, 10 to 11 days. So we have logistical advantage. However, our disadvantage is domestic logistics. All our Canadian commercial hydrogen is produced in Edmonton. And then from Edmonton to Prince Rupert, there's about 1,500 kilometers of rail. So you have to put hydrogen into ammonia rail tanker, ship it to Prince Rupert, and export it. Currently, there is a federal government liability clause, unlimited liability clause. So there's a task force between federal government, provincial government, and industry to navigate this logistic and insurance cost. And then once it can be resolved, we'll be the global superpower of exporting hydrogen to Asia. In summary, I think there are some 5 key areas of collaboration. You can produce hydrogen in Alberta and export. It's a little bit of mid to long-term opportunity, but it's still there. The second is hydrogen for data centers, so hydrogen for AI usage in Alberta. Third and fourth is more focused on R&D collaboration. If Korean companies or government agencies or R&D institution wants to conduct focused R&D, then we have matching institutions and academia. Last is AI for hydrogen. We can talk about hydrogen for the AI industry, but we can also talk about developing AI to advanced hydrogen economy. So those are also some opportunities. And this is forward-looking potential opportunities only, so and publicly available info. Based on timeline of energy transition and the economic impact, that's what we see from our office. There is existing opportunities between Canada, Korea, and Alberta. We've been traditionally exporting natural coal, metallurgical coal, thermal coal, oil, natural gas, pipeline safety, critical minerals. But going forward, some low-hanging fruits or immediate opportunities include joint feasibility studies between Alberta and Korean stakeholders to further advance various opportunities. There's R&D partnerships, energy safety, circular economy, or hydrogen-related standards and codes. Going forward, joint CCS project or pilot projects for Korean companies to test and pilot and commercialize and develop projects together and go overseas. And even further, you can produce hydrogen from Alberta, use it for industry for blue steel or data centers, or even looking forward, SMR, small modular reactors as well. So with that, that concludes my presentation. I have 20 seconds. Today, I'm here with my team member, Gil, from Alberta, Korea office. So we look forward to networking with you after this seminar. Thank you very much.
Thank you, Victor, for sharing those insights. Does anyone have any questions? No? If not, our next speaker is Namgi Kim, Mechanical Engineer at AVL Fuel Cell Canada, presenting Introduction to AVL Fuel Cell Canada. Please welcome Namgi.
Good afternoon, everyone. My name is Kim Namgi, and I'm an employee at AVL Fuel Cell Canada. And today I'll give you an introduction to our company and showcase what we're capable of. Okay. AVL Fuel Cell Canada is an affiliate to AVL, and we are AVL's global center of excellence for PEM stacks and electrolyzers. To give you a little bit of background, AVL is headquarters in Austria, Graz, and they are the world's largest independent company for development, simulation, and testing in automotive industry and other sectors. With 29 locations around the globe, AVL is able to provide sales and technical service to companies all around the world. Typically, AVL have been operating in countries with automotive OEMs, which includes Europe, North America, and here in Korea as well. At a glance, AVL was founded in 1950, so it's been around for a long time. It has now grown into more than 12,000 employees globally. And one of the things about AVL is that it really prioritizes on innovation. And we have spent a significant amount of resources in innovating and research and development. Three main divisions in AVL. First, we have the Advanced Simulation and Technologies. This focuses on creating models such as CFD or performance and degradation models. Next, we have the Instrumentation and Test Systems, where we create test beds. And finally, we have Powertrain Engineering, where we help consult and create designs for our customers. And AVL Fuel Cell Canada primarily operates in this Powertrain Engineering division. So focusing back on AVL Fuel Cell Canada, we are a relatively new affiliate, but we have a number of employees who've had extensive years of experience working with PEM fuel cell, as Vancouver is home to a number of world-class companies. Leveraging off of this experience, we're able to provide design engineer and prototype, and test custom fuel cells and electrolyzer stacks. Just to give you a little bit of background, AVL Fuel Cell Canada primarily focuses on component and stack level. However, we do work with AVL Global to help meet customers' needs in stack system integration and system and application integration as well. And in the past, we have successfully completed projects in working in this collaborative manner. Some of the specific areas of AVL Fuel Cell Canada where we have a lot of knowledge, there's 3 that I would like to highlight. First is design of bipolar plates. We have employees with experience working with carbon and metal bipolar plates. Another area of expertise is design of membrane electrode assembly, and this includes electrodes, membrane, CCM, GDL, and for electrolyzer, PTL as well. Finally, we have experience in design of stack hardware, which includes end plates and compression systems. And combining all these 3 areas of expertise, we're able to provide a comprehensive design of fuel cells or electrolyzer stack. And we're also able to provide a range of stack-related services to help in our design. In our state-of-the-art R&D infrastructure in Burnaby, we have 2 areas I'd like to highlight. First is our prototyping lab. While we do not have the capability to mass produce stacks, we have the capability to produce small quantities where we can show our prototypes, and we can use these stacks for design verification tests such as performance and long-term durability. We also have a hydrogen-safe lab where we have a number of testing platforms. We have 4 subscale stations which are focusing on component benchmarking and screening, and we have 4 short stack and 1 full stack test bed to focus on design verification tests. To give you a little bit of some of the projects that we've had, so leveraging of the innovations that we have with the bipolar plates, MEAs, and stack hardware, we have come up with a number of stack designs, which we then use as a base for customer projects. One thing I would like to highlight here is that we have experience working in a wide range of industries. So in the past, we have worked with commercial vehicle OEM, marine OEM, air-cooled stack for drones, as well as multi-megawatt PEM electrolyzer stack as well. To go into a little bit more detail, this is a picture of our Gen 1 PEM fuel cell stack. It has a rated power of 200 kilowatts with a peak power rating of 330 kilowatts. Using carbon plates, it has high efficiency, and with our in-house testing, we've been able to showcase that it has free startup capabilities from minus 30 degrees, and it has extensive lifetime durability as well. Now I would like to discuss to you with some of the innovations that we're looking into at AVL Fuel Cell Canada. So one area I would like to highlight for PEM stack is in intermediate temperature and high temperature. What we've found is that there are certain sectors such as aerospace and heavy industry where they're looking to operate PEM stacks at a higher temperature. And currently we're looking in innovations using different technologies to push the PEM stack, which traditionally operates up to 90 degrees Celsius at stack outlet temperature. We're trying to push this to at least 120 degrees, which we call intermediate, and even all the way up above 200 degrees for high temperature application. In conjunction of coming up with innovations in terms of material selection, we're also upgrading our lab capability to support our design choices. Another area of innovation that we're looking into right now with PEM stack is in lightweighting our stack designs. So here we are working with Red Bull and taking our Gen 1 stack, which I've shown you before, and identifying ways to reduce weight and thus increasing the power density. We're doing this in 2 steps. First, we have already completed the first step, which focuses on the outer stack compression, stack hardware side, which has given us about 30 kilogram reduction in weight. And right now we're further looking into additional areas where we can further decrease weight and increase our power density. The next area I would like to showcase to you is in PEM electrolyzer. So with the wealth of knowledge that we have in the company, we found out that there is great synergy between PEM fuel cell stacks and PEM electrolyzer. And last year, we decided to take on this project. And within the course of the year, we were able to design, develop, and build a prototype and test a fuel cell electrolyzer stack, which meets the US Department of Energy targets. A model of the stack is available for you to view downstairs at the Canadian Pavilion if you want to see. But this is a project that we are we feel very accomplished in the company for making this stack. This stack right now, we're looking into further improvements. We know that the market is looking for multi-megawatt solutions for PEM electrolyzer. And so we're looking into different areas on how to improve upon our initial design. The last area I would like to discuss to you is in AEM electrolyzer. So this is a technology that is not as mature as PEM stacks and PEM electrolyzer, but AVL feels like this is an area where we could see potentially a lot of growth in hydrogen generation. 3 areas with AEM which we focus on. There's first the supply chain definition. So here we're looking for companies that we would work together with to provide us with next generation MEAs and CCMs. In the past, for PEM stacks and electrolyzers, we have had very good relationship with our suppliers where we would get the product and we would provide valuable feedback back and help develop the products. And this is something that we're looking to, this kind of a relationship is something we're looking for in the AEM electrolyzer world as well. The second area of AEM is in stack development. So here we're looking for any companies that are looking for stack design in their application where we'll be able to provide our expertise and help come up with a stack design. The last area of AEM is related to testing services. So here we're looking for anybody who have AEM technologies that they want to help test and validate. We'll be able to perform both at component level and at stack level to show for performance and or durability. Jumping back to stack development, we do have an R&D stack in development for AEM. We've started earlier in this year, and right now we're currently in the prototyping phase right now, and hopefully we'll be able to get some test results early in Q1 of next year. And we're hoping that this would be some stack design that we'll be able to base off of for any customer who are looking to for any stack design for their own. And that concludes all my slides. Thank you everyone for listening, and hope you have a good rest of the day.
Thank you for the presentation. Next, please welcome Grace Kwan, President and CEO of Hydrogen in Motion, presenting infrastructure independent energy with H2M's innovative hydrogen storage material.
Sorry, it's a little high, or maybe I'm a little short. Good afternoon, everyone. I'm Grace Kwan, President and CEO of Hydrogen in Motion. We've developed a nanomaterial that stores hydrogen under low pressure. Am I pressing the wrong button here? Yes, next slide, please. Oh, okay. Sorry. Down button. There we go. My apologies. Okay, so a little bit about Hydrogen in Motion. I'm the co-founder and CEO with my colleague Mark Cannon, who's the CTO and is here at the show. We founded Hydrogen in Motion to address one of the major problems in the hydrogen economy, which is hydrogen storage. Our vision was to address climate change by bringing clean energy to fruition, and that through the vehicle of solid-state hydrogen storage. So what's holding hydrogen back? I call hydrogen storage and transport the silent killers of hydrogen projects for 3 reasons. One is it's very capital intensive. Many project developers don't budget enough for hydrogen storage. It's about the same price as your electrolyzer or your fuel cell. So it's usually people are an order of magnitude short for the storage. The high pressure is complex and expensive. And then there's no hydrogen infrastructure. So it's a challenge, the storage and transport. There's a number of different hydrogen storage options. Liquid hydrogen, it has a challenge of cryogenic losses, boil off. Liquid organic carriers, which have low efficiency. It takes about much power to get the hydrogen in and out as the power that you're carrying. Ammonia has very well-known toxicity issues, and high pressure has a complexity of high pressure. So what's our solution? Finally, we get to this. Hydrogen in Motion has developed a solid-state hydrogen material. It's a carbon-based that has been designed at the quantum level, doped and decorated with nanomaterials specifically to attract hydrogen. We add a small amount of pressure, so 50 to 80 bar, and we're able to get equivalent storage to 700 bar, but in a smaller tank. So it's this mechanism uses van der Waals force or physisorption, so it's not like metal hydrides, which split the hydrogen molecule. This one keeps it as the molecule, therefore it's energetically more efficient at storing and releasing the hydrogen. You can see at our comparison of tank size, it's about 1/3 smaller than a 700 bar tank and about half the size for a 350 bar tank. So at 50 bar, of course, you have 90% less pressure. So you can save in both the CapEx and the OpEx. Our value proposition is on in 4 dimensions of safety, affordability, gravimetric and volumetric density. We have considerable advantages against batteries and other storage technologies. And we've been in business since 2014, so we have a suite of material. I was just talking about the P100 series, which is the carbaceous material. We do have a metal hydride that stores and releases at room temperature, which is unusual for metal hydrides. And we have a chemical storage, which has a very high density and a long duration, very similar to batteries, but they don't have a release. So hydrogen in motion, we've been thinking about hydrogen storage, and we think hydrogen is not like buying a computer. You can just plug it in a wall. Your building is already wired up. When you have a hydrogen product, you actually have no infrastructure. So the challenge is bringing everything to the table. So we've put together a concept called infrastructure independent energy. We put together renewable energy, about 30 kilowatts, 9 solar panels, 4.8 kilowatt electrolyzer that generates 2 kilograms of hydrogen a day. And what can you do with 2 kilograms of hydrogen? Well, if you're using fuel cell, that will give you about 33 kilowatt hours of power, which in North America is your average home. And you can fly your UAV, for those who have a UAV, for 1,000 kilometers, and drive your car for a couple hundred kilometers. Or you can also burn hydrogen. So in Canada, we have cottages, and people are off the grid, so they power their appliances using propane or natural gas. So you can also apply that with hydrogen. And I think my marketing team just did this to challenge me, but they put a picture of an excavator in as burning hydrogen. I don't know anyone who has an excavator at home, but apparently they do. So one of the things that we're thinking about is our tanks are swappable. So we have a concept of, we call H2U. It's peer-to-peer trading of hydrogen. It's very similar to the concept of Airbnb has monetized your spare room, and Uber has monetized your car. This would monetize your ability to generate power, and through our platform, you would be able to share it with your neighbors or the community center, or however you wish to do so. We can also do this in very large scales. This is a future project, but we plan to be able to put hydrogen in shipping containers. We believe we can store 1.3 tons of hydrogen in a 40-foot shipping container. That's 2.5 times of any hydrogen storage that's available on the market now. And that way you'll have dispatchable power from renewable fields. Why invest in hydrogen? I think most people at the room already know these stats, but there's new markets. Climate change is not going away soon. We can talk about transport diversification and scalable solutions, which is what Hydrogen Motion is bringing to the table. We've looked at different markets, and we're moving from the very high-cost, price-insensitive market of UAVs that require small tanks to microgrids, which was the peer-to-peer network that we talked about. Vehicle retrofits, so you can burn hydrogen in vehicle retrofits, and that gives you an 80% GHG reduction, which is a great way to transition society. And then energy exports, which is the large-scale transportation of hydrogen. For Hydrogen Motion, we have a bunch of customer validation projects, from drones to racing cars to putting hydrogen on an island. But these are all things that is in the pipe. Right now, we've made our pilot plant and are raising equity round. And then, these are use of funds. And that's it. I'm happy to discuss afterwards if you want to talk about Hydrogen Motion. Thank you very much.
Thank you, Grace. Our next presenter is John Lee, Director of PSA Sales at IVUS Absorption. He will present advanced fast-cycle rotary valve PSA for high-purity hydrogen purification. Please join me in welcoming John.
Hey everyone, and good afternoon. My name is John Lee. I'm the sales director for PSA products at IVUS Absorption. So who is IVUS Absorption? So IVUS Absorption was founded in 2023 to acquire the clean tech business, the entire clean tech business from a company called ZBEC. The leading investors for the acquisition is Inbridge, and then another company called IVUS Energy Solution. Perhaps, and some of you know that, and Inbridge is one of the largest energy company in North America. So IVUS Energy Solution is a Massachusetts, US-based company. It's very active in hydrogen refilling station and also EV charging station design, build, and deployment. So I would like to point out that the acquisition of the clean tech business from ZBEC, including a very key technology, that is the rotary valve pressure swing absorption. So our company, the headquarters is located near Montreal in Quebec province in Canada. And we have a very nice and modern facility in there that is home to about 100 staff members. So we are a ISO 9001 certified company, and also we are certified to design and manufacturing pressure vessels per ASME, CRN, and PED standards. And so what we do at Avis Absorption, we design, manufacture, and service perhaps the most advanced gas conditioning and purification systems. So those products are being used by our customer to generate clean and renewable gases and energies to enable a circular and sustainable futures for our planet. So that's what we do. And the gas purification systems we design are mostly based on the two core technologies we have. The first one is pressure swing absorption, or PSA. The second is temperature swing absorption, or TSA. Or PSA-based system, and they have multiple vessels, typically 6 or 9 absorption vessels. All of those systems using the rotary valve technology to control the gas flow in or come out from these absorption vessels. So this is very different from the conventional PSA you see on the market. In conventional PSA, and a large number of on-off control valves are used to control the gas flow. And, but we do not use that. We use rotary valve to control the gas flow into different vessels. Or PSA-based system can be used to handle or process a feed gas composition that is rather complex with many or multiple impurities. Where PSA can remove those impurities and achieve very high products gas purity. So, and the PSA systems are designed mainly for hydrogen purification and for biogas upgrading, and also for other industry gas purification applications. Or TSA-based systems are quite simple, much simple. Basically, you usually have 2 vessels, and they are mainly used for gas dehydrogenation application. So currently, we offer 3 product lines for gas purification. The first one is our industry PSA. So those systems are all using rotary valve technology. So the system, the PSA system, are used for high purity hydrogen production and also for high purity helium production. And also lately, we expanded the application of our PSA system to CO2 capture. The second product line we offer right now is biogas upgrading system. So those are also PSA-based systems. They can be used to generate pipeline-grade renewable natural gas from a wide range of biogas sources. So this including the digest gases, the landfill gases, and also wastewater treatment plant. Our third product is the dryer, which are being used to remove water from hydrogen gas generated by the electrolysis process, or can also be used to remove water from air or compressed natural gas process gases. So those are the 3 product lines currently we offer. To support the installation and the operation of our equipment at the customer side, we have a dedicated customer service team. So this team of aftermarket custom care service, such as supplying replacement parts to our customer or to support, to providing technical support for our equipment to our customer. So when used for hydrogen purification, or PSA system offer a number of unique features. First is that they can achieve very high hydrogen purity, up to 6 nines if needed. So achieving 5 nines, 6 nines actually are quite common for PSA application. The second way is that they are very compact because of the use of rotary valve technology. Compared to conventional PSA, even at the same capacity, or PSA typically is at least 3 to 5 times smaller. And our PSA is also extremely reliable because by using rotary valves, we eliminate the use of the large numbers of on-off control valves, which you see in conventional PSA. Those on-off valves are moving parts, and they close open every few minutes. So they are the high failure point for PSA operations. So by eliminating those on-off valves, the reliability of our products became much better. So, and right now, our PSA systems are all fully pre-assembled and unskidded. So the vessels, the valves, the pipings are all installed in our shop. The adsorbent is also pre-loaded into the vessels. So we ship the whole skid to the customer site, and the installation and the commissioning and usually can be finished in 1 or 2 weeks. So this is very short for a scale like this. It saves a lot of time and money for our customer. The operation of our PSA is extremely simple. And during the normal operation, there was only one control parameter which need to be controlled. That is the rotating speed of our rotary valves. So it's very, very simple. Because of that, many of our customers actually wrote their control program by themselves. Of course, with support of our engineers. And by specification, by design, all of our PSA system can be operated at least 40% of the design capacity. But many of our systems can easily run at 30% of the design capacity. So it has a wide operation range. The electrical power is the only utility needed to operate our PSA for most of cases. Even for a PSA unit with a capacity like produce 5 to 10 tons per day of hydrogen, the power consumption is about 1 kilowatt. So very low OPEX. So those are the unique features of our rotary valve PSA. Currently, we have over 350 PSA units deployed worldwide for hydrogen purification. The application including renewable hydrogen generation, and by using biomass, municipal solid waste or industry waste like tires through gasification or pyrolysis. The PSA also being used for hydrogen hubs, where that hydrogen is produced at a central location and then trucked to different sites, the different use location. Because our PSA is very compact, they are being used for on-site hydrogen generation, for example, in the hydrogen refilling station. And also in recent years, I think a couple of speakers mentioned ammonia, and ammonia has been viewed as a hydrogen carrier. At the point of use, ammonia can be cracked to generate hydrogen and nitrogen mixed stream, and then our PSA can be used to extract the hydrogen out from that gas stream. Those are the typical applications of our PSA. So this slide just lists the typical feed gas our PSA can process, and then to generate high purity hydrogen. So the typical methane steam reforming, ATR reforming, And those are the very common application for PSA. So recently, as I mentioned, in recent years, we see more interest in gasification as well as in ammonia cracking. So one point I would like to point out is that our PSA can handle saturated water vapor in the feed. So as long as the water is in vapor phase, it does not need to be removed. Our PSA can handle it, can remove it to remove it from the hydrogen stream. So in the next few slides, it's just some just show some actual application cases of our PSA. So this one is located in Long Beach Port near Los Angeles in California, US. So the plant actually generates 3 products: electrical power, heat, and hydrogen. So our PSA is used to recover hydrogen from a solid oxide fuel cell waste stream. As you can see here, the hydrogen content in the feed gas is only 26%, very low. We supply a 2-stage PSA, and then we can get the hydrogen purity to over 5 nines. So, this is an on-site hydrogen generation cases. It's located in Korea here, and as you can see, and our PSA is packaged into a container, and then this container is shipped to the hydrogen generation site. Many of our PSA units are being used in petrochemical industries. As you know, that the reliability requirement for petrochemical industry is very high. The equipment cannot be allowed to shut down frequently. So we have many of units and running at the petrochemical plants. So this one is located in Poland, and it was commissioned in 2002. So it's still running today. So it's about already 23 years. So the feed gas to the PSA is standard methane steam reforming syngas, and then our PSA get it to 3.9 purity. So this is another example of what PSA used in a gas processing plant. It's located in Japan, and actually I just visited this plant last week. So the unit is still running, and it is, I think, near 20 years lifetime. So I think that's all what I want to present, and thank you very much for your attention.
Thank you for that presentation. Our final presentation today comes from Tanya Smutny, Engineering Team Lead at Power Tech Labs. Please welcome Tanya with a warm round of applause.
Hi, everyone. I am here today to talk about Power Tech. We are located in beautiful British Columbia, Canada. We are a subsidiary of BC Hydro, which is the electric utility for the province of BC. We are one of the largest testing and innovation labs in North America, and we consist mainly of technologists, engineers, scientists, and PhDs. Recently, we acquired a company in Boston, USA, which is now PowerTech USA. Our organizational structure, so we are here representing the hydrogen testing team, which is part of the testing group. We also have an engineering group, a hydrogen infrastructure group, which is a separate business unit, and our business operations group. PowerTech has a very long history in hydrogen. We got our start in the 90s in hydrogen, and our history includes designing and building some of the first non-commercial hydrogen fueling stations. And more recently, we have achieved 350 gram per second high flow testing, as well as the first non-commercial hydrogen truck fill in 10 minutes. Our infrastructure group designs and builds dispensers, as well as stations and testing devices. Some of their capabilities, obviously light duty, getting into heavy duty, and then as well super heavy duty. Our Partech USA team builds mobile refuelers, and we have a capacity of 1,000 kilograms of hydrogen storage. Onto our testing team, which is what we are here to represent for the most part. So we are able to certify and test hydrogen cylinders. This is mainly type 4 cylinders for the vehicle industry, but it doesn't exclude any of the other types of cylinders that are out there. So we are able to perform hydraulic testing at high temperatures, low temperatures, and ambient temperatures, as well as burst testing, chemical exposure testing, any sort of damage tolerance testing, fire testing, and penetration testing. Also in this lab, we have a pneumatic testing facility where we are able to hydrogen gas cycle cylinders and entire fuel systems, as well as heavy-duty cylinders and fuel systems. In our component testing facility, we have a very long list of testing that we are able to perform, and this is for any component that is in the hydrogen fueling station or in the vehicle at high pressure. So this includes things like the nozzle, receptacle, hoses, valves, OTVs, etc. This is an example of the highest flow we have achieved through a nozzle receptacle, peak flow of 378 grams per second. This was only 2 years ago. And we have the advantage at PowerTech of having the support of a number of other laboratories, such as the chemistry lab, a materials lab, a mechanical lab, and things of that nature. And they are able to assist us with testing of any of the materials inside a tank, such as the liner, which is made of plastic in a Type 4 tank, and of course, the metal of the OTV, and the fibers and the resin. We are a ISO 17025 certified lab, and we have extensive experience working with all sorts of certification bodies from around the world. And we are very actively helping on standards committees as technical experts. And that concludes my presentation. Thank you.
Thank you, Tanya. To conclude today's seminar, I would like to invite Derek Kim, Managing Director of the Trade and Invest BC Korea office, to deliver the closing remarks. Please welcome Derek Kim.
Thank you, Jennifer. Distinguished guests, colleagues, and partners, I know it's been great about 2 hour session today. Thank you for your time. So on behalf of Trade Commissioner Service, Alberta Korea Office, Canadian Hydrogen Association, and the Trade and Invest BC Government of British Columbia, I'd like to extend our sincere appreciation to all the presenters and participants for today, especially those who came from all the way from Canada. Over the past 2 hours, we heard from the leading Canadian hydrogen innovators, from fuel cell companies to advanced materials, storage, and mobility technologies. These companies represent not only Canada's technical leadership, but also the strong commitment that we share towards building a clean, reliable, and scalable hydrogen economy. Korea is one of Canada's most important partners in the hydrogen and clean energy space. Today's session reaffirmed the strong complementaries between our two nations. Canada's abundant clean energy resources and world-class R&D capabilities, and Korea's industrial strength, global manufacturing network, and rapid commercialization capacity. Going forward, our team from Canada, Alberta, BC, Canadian Hydrogen Association, altogether remain fully committed to acting as bridges between Canadian and Korean partners. Whether it is facilitating industry connection, supporting pilot projects, or helping to navigate investment opportunities. We are here to help accelerate meaningful collaboration. I hope today's session leads to new partnerships, concrete business opportunities, and deeper engagement across both ecosystems. Thank you again for your time, your insight, and your continued interest in the Canadian hydrogen sector. We look forward to staying connected and support your next steps. Thank you.
Thank you again to all our speakers and participants for joining us today. 이상으로 세미나는 마치겠습니다. 저희 행사에 관심 갖고 시간 내어서 와주셔서 감사합니다. 이어서 저희 3시 반부터 캐나다 국가관에서 간단히 네트워킹 세션을 진행할 예정인데 관심 있으신 분들은 7D71 부스로 오셔서 저희 업체들이랑 인사하시고 이야기 나누시기 바랍니다. 감사합니다.